Welcome to BTech Revision. In today's lesson, we're looking at capacitance. By the end, we should be able to calculate the capacitance, charge, and voltage of capacitors. How do objects store charge? They store charge with capacitance, which is the ability of a system to store an electric charge. And we can calculate this via the equation capacitance equals charge divided by voltage. And the short form is C equals Q over V. Is measured in coulombs. Voltage is measured in volts. And the units for capacitance has a special unit called the farads, F for short. And we can spell farad as F-A-R-A-D. Capacitance usually has the prefixes of micro, nano, and picofarads, where micro is 10 to the power of minus 6, nano is 10 to the power of minus 9, and pico is 10 to the power of minus 12. Typical values of capacitance can be from electrolytic capacitors, which would have a range between 1 microfarad to about 1. And another example would be mica, which has a range of 1 picofarad to about 1 microfarad. The following symbol is the symbol for a capacitor. How do they work? If we take a look at the circuit below, we have a cell, and we have the negative, which is the shorter side of the cell, and the positive side, which is the longer. So if we consider a circuit that is connected to a capacitor, we have electrons that will be moving along the wire, and they will store on one side of the plate. And these electrons will be moving around the circuit. Therefore, the other side of the plate will become positively charged. This creates an electric field that is capable of moving any other charged particle that is placed between the capacitor plates. And when we remove this cell and replace it with a resistor of some sort, then the electrons would get pushed back in the opposite direction. And that is originally stored as electrical potential energy in the capacitor will be transferred to the capacitor, transferred to the components in the circuit. Now, let's look at an example. A capacitor stores a charge of 15 microcoulombs when connected to a voltage of 5 volts. Calculate the capacitance of the capacitor. We can start by writing down our equation. Capacitance equals charge divided by voltage. We know the charge is 15 micro, which is times 10 to the power of minus 6 microcoulombs, divided by the voltage of 5. And if we work this out, we should get a value of 3 times 10 to the power of minus 6 farads. And we know 10 to the power of minus 6 is micro. So we can rewrite this as 3 microfarads. For capacitors that have parallel plates, we can also use this equation, which is capacitance equals permittivity times area divided by the distance. And if you remember from last lesson, permittivity, also known as absolute permittivity, is equal to epsilon r times epsilon naught, where epsilon r is the relative permittivity and epsilon naught is the permittivity of free space. The units for area are meters squared, distance is meters, and capacitance is farads. The short form is capacitance equals permittivity, which is epsilon times A for area divided by the distance d. And we can rearrange this for permittivity. So permittivity equals capacitance times distance divided by area. And we can use this formula to work out the unit for permittivity. And we know that's going to be farads for capacitance. D is distance, which is measured in meters. A is meters squared. So the meter with the meter squared can cancel, and we're left with farads per meter. And the epsilon R, relative permittivity, is also known as the dielectric. And if you remember from last lesson, the values for this can be 1 for air, and water will have a value of 80. Now, let's take a look at an example. A parallel plate capacitor has an area of 0.1 meters squared and is filled with a dielectric material with a dielectric constant of 5. If the separation between the plates is 0.02, calculate the capacitance of the capacitor. We can start by writing down our equation. Capacitance equals epsilon naught epsilon r times the area divided by the distance. And we know epsilon naught from previous lesson, permittivity of free space, is 8.85 times 10 to the power of minus 12. So we can write that here in our equation, times epsilon r, the dielectric, which is 5 in this case, times the area of 0.1 divided by the distance 0.02. And plugging all these values in to our calculator, we get 2.21 times 10 to the power of minus 10 farads. And we can also write this as 0.221 times 10 to the power of minus 9 farads, and we know minus 9 is nano. So that is 0.221 nanofarads. Now pause the video here and attempt this exam question. The capacitance of a parallel plate capacitor with square plates is 80 microfarads. If the separation between the plates is 1 centimeter and the dielectric material used has a dielectric constant of 6, determine the length of the plate. We can start by writing down our equation. Capacitance equals epsilon naught epsilon r area divided by the distance. And I think for this question, it'd be a good idea to draw a quick sketch of plates, just so it's clear exactly what is happening. Now, we can see that we have square plates. So that means the lengths are going to be the same. Okay, we can label that as L. And we know we have a capacitance of 80 microfarads. So capacitance equals 80 times 10 to the power of minus 6. And we know the distance between each plate, D, is equal to 1 centimeter. So that's times 10 to the power of minus 2 meters. The dielectric is 6, and we just need to find the length of each plate. So if we look, the length of each plate is linked to the area of the plate. We know the area, since it is square plate, the area of a square is just the length squared. So if we work out the area first, then we can use the area to work out the length. So let's rearrange this equation for area. So that would give us area equals capacitance times distance divided by epsilon naught, epsilon r. We know the capacitance, 80 times 10 to the power minus 6. We know the distance. 1 times 10 to the power minus 2. That would be the distance between the plates. And we have our constants. Permittivity of free space, 8.85 times 10 to the power minus 12. That would be times by the dielectric, 6. And working all of this out gives us a value of 1.507 meters squared. So we know the area is this, and we know the area is equal to L squared, or length squared. So to work out the length, we just have to square root our answer here. And therefore, the length is 1.23 meters. And that's the end of the lesson. If you would like to boost your grades, visit us at btechrevision.com, where there's lots of quiz questions and more resources. See you next lesson.